Okay, today we are going to learn about magnetic flux, which you did not know magnetic flux as 5. So what is actually your magnetic flux? So for a magnetic flux is actually a dot product or by your magnetic flux density factor, which you denote as B, and the area factor, which you denote is A. So it's actually dot product between your magnetic flux density B and the area vector. In short, we can write it in an equations or formula, which is your magnetic flux density. Magnetic flux is equal to magnetic flux density dot A. So you have to take note in this definitions. So for your vector A, the first thing about your vector A, your vector A is always perpendicular to the surface. Your vector A is perpendicular to the surface. What is this means? So let's say you have a surface here. This is your surface. Okay, let's say this is your surface. So the vector A will be in this direction, perpendicular to this. Let's say your vector, your surface is in this direction, or here. This one is your surface. Then your vector A will be in this direction, okay, which is always perpendicular to the surface. Okay, so for example, you have a surface here. This is your surface. So this one is your surface, while this one is your vector A. Okay, so the second thing for this one, because we know that phi is actually the product between B and A, so phi is a scalar quantity with the unit Weber WB. So this one is the unit of your magnetic flux. Okay, so take an example. So for example, you have these questions. When there is a B passing through a surface, so this one is your surface, and your B pass through in 90 degree. Okay, let's say your B is in this direction and this one is your surface. So the first thing you have to find out where is your vector A. So remember, your vector A is always perpendicular to the surface, which means that this one is your surface. This one is your vector A. So because theta, so magnetic flux is actually equal to B dot A. In other words, we can written it as BA cos theta. So what is this theta? So theta will be equal to the angle between B and A, right? The B and A. So because A and B are in the same direction or parallel to each other, so at this question, so theta is equal to 0 degree. So in other words, you will become, your magnetic flux will be equal to BA cos 0 degree, which is your BA, because cos 0 is 1. Okay, so let's say you have the second example. Okay, so for the second example, if a magnetic flux density passing through the surface with an area making with the surface as 30 degree. So this one is your surface, this one is your magnetic flux density. So let's say your magnetic flux density is in this direction. It passing through the surface in this direction, which makes an angle 30 degree to the surface. So how do you calculate your magnetic flux? So magnetic flux will be equal to B dot A. So in other words, is BA cos theta. So theta is the angle between B and A. So for these questions, your theta cannot be equal to 30 degrees. Why cannot be equal to 30 degrees? Because your vector A is actually perpendicular to your surface. So this one is your vector A, which is not here. Your A is not at here. So your A is perpendicular to this surface. So we have your angle between B and A is actually here, 60 degrees. So your theta is actually 60 degrees. So cos 60 is equal to 1 per 2. So we have your BA cos 60. So it's actually 0.5 BA. So remember, the unit is Weber. Okay. So you may write it in WB. This one is your unit. Okay, now, then, what if there is a coil which has n turns of coil? N is the number of turns. For coil. So let's say the magnetic field passing through the coil. So this magnetic field or magnetic flux density that passing through the coil will produce the magnetic flux. Okay, but because there is a number of turns, so it means that we have a multiple area or multiple of coil which causing the magnetic field flux density to be cut. So here, if we want to find magnetic flux linkage or the total magnetic flux, so we call this the total magnetic flux that passing through a coil as magnetic flux linkage. So magnetic flux linkage is actually, you can imagine it as a total magnetic flux that passing through the coil or the n turns of coil. So in other words, which is your n phi. So n here is your number of turns for coil. Okay, and here is the number of turns for a coil. So for example, you have this. So let's say you have a magnetic field which is equal to magnetic field at here, which is your magnetic flux density B is equal to 16 millitesla, passing through a coil. So it will passing through a coil perpendicular to the coil. Okay, which your n will be equal to 30 turns. So this area of your coil is actually equal to 48.0 centimeters squared. So how do you calculate this example, or how do you calculate the magnetic flux linkage for this case? So you know that magnetic flux linkage is equal to n phi. So phi is B dot A. Okay, so the area is actually in this direction, which is perpendicular to your surface, which is perpendicular to your surface. So actually your A is in this direction. So we know that A and B are in same direction, so the equation will be equal to NBAY. Cos 0 will be equal to 1. So in other words, you have your N is 30 turns, so your B is 16 millitesla, and also your A will be equal to 48 times 48 centimeters square. So you have this equation. So in other words, you want to calculate a magnetic flux linkage, so you just press 30 times your 16 milli and times your 48 centimeters square. So you will get your magnetic flux linkage. So magnetic flux linkage is actually the total of your magnetic flux. So in other words, it has same unit as your magnetic flux. So your answer should be written as Weber, WB. So that's it for this lesson, which you learn about your magnetic flux and also magnetic flux linkage. Okay.